Welcome back to AI Unraveled. Today, we are killing the magic. For 3 years, we've been obsessed with the spectacle of AI, the poems, the art, the viral demos. But in 2026, the bill has come due. We are entering the era of the substance pivot. In this episode, we are dissecting the silent failure epidemic. Why AI coding assistants are creating software that looks perfect, but is rotting from the inside. We'll look at the DeepSeek shock, where a $5.6 million Chinese model just proved that Silicon Valley's trillion-dollar moat is an illusion. And we'll ask the hard question, why is the United States, the country that invented modern AI, falling to 24th place in actual adoption? But first, are you drowning in dense legal text? DjamgaMind is the new audio intelligence platform that turns 100-page mandates into 5-minute executive briefings. Start your specialized audio briefing today at DjamgaMind.com. Now let's unravel the reality.
Welcome back to AI Unraveled. It's January 24th, 2026. And I want to start today by asking you to just look at the calendar for a second. Because if you've been operating in the tech sector or in finance or really any leadership role for the past 3 years, today feels fundamentally different.
It really does. It feels like the lights just flickered on at 2:00 a.m. at a massive warehouse party, and the music has just, screeched to a halt.
That is the perfect analogy. I mean, think back. We just spent 3 years completely drunk on this spectacle.
Oh, completely. The magic era, right.
The magic era.
Hey.
We were watching these demos of robots folding laundry, which, they could never actually fold in a real house. We were generating these surreal images of, astronauts riding horses on the moon.
And asking chatbots to write Shakespearean sonnets about our quarterly earnings reports.
Exactly. It was fun. It felt limitless. But the party, as you said, is over.
It is. And, if you've read the manifesto that Microsoft CEO Satya Nadella just put out this month, he's basically the one who turned the lights on. The headline is, From Spectacle to Substance.
And this isn't just, like, corporate PR fluff, is it?
No, not at all. This is a declaration. Nadella is effectively declaring the end of the hype cycle and the beginning of what we're calling the Great Sobering.
The hangover is here, and it is hitting hard. We're no longer asking, what can this cool demo do? We're asking, does this actually work in production?
And more importantly, what happens when it breaks?
Right. And frankly, the answer we're getting from the data right now is, it's pretty alarming.
It is. We're seeing, really, a convergence of 4 distinct crises all hitting at once.
Okay, let's lay them out.
First, you've got the engineering collapse. The actual foundational quality of the code in our software infrastructure is, it's rotting from the inside out.
We'll get into the data on that. It's shocking. What's number 2?
Number 2 is the macro lag. The United States, the country that started this whole thing, is, believe it or not, falling way behind in the adoption race.
We're losing.
We're losing. Third is the agency gamble. This is the life and death legal question of who is liable when an AI makes a decision. We're seeing some brilliant successes, like in Utah, and some total disasters, like at Air Canada.
And the 4th crisis.
The economic shock. An architecture called DeepSeek has just completely, and I mean completely, broken the premium pricing model that the entire industry has been built on for the last 3 years.
So we have a massive amount of ground to cover. We are unpacking this huge transition from magic to metrics. And if you're a CTO, if you're a product manager, or frankly just someone trying to make sure your company survives 2026, this isn't about the future anymore.
No, this is about right now.
This is about the survival metrics you need today. We're moving from an era of time to hello world to a new era of time to trust.
As we're about to see, that trust metric is currently in free fall.
Let's get into it.
Let's do it.
Okay, I want to start with the code itself, the foundation. Because for the last 2, maybe 3 years, the dominant narrative, the sales pitch we heard from everyone was that AI makes developers 10x.
The 10x developer, yes.
You just, tab complete your way to a finished product. It's easy.
Yeah.
But we have this forensic audit here from a company called GetClear. And this isn't a small sample. They analyzed 211 million lines of code from 2020 through the end of 2025.
It's a massive data set.
A massive data set. And the picture it paints is not the 10x dream. It's a technical debt nightmare.
And, to really understand why this is happening, you have to look at the fundamental shift in how developers are actually behaving. The workflow itself has changed.
Okay, walk me through the before times.
The before times. So pre-AI, the workflow was pretty straightforward. It was think, code, test. A developer had to really internalize the logic of the problem. They had to build a mental map of what they were trying to solve. Then they'd write the syntax, manually, line by line, and then, crucially, they'd write and run a unit test to prove it worked.
It was slow, maybe, but it was intentional.
It was incredibly intentional. They had built the thing brick by brick, so they knew where every brick was.
And now, fast forward to today.
The workflow has shifted. It's now prompt, generate, vibe check.
Vibe check.
Yeah.
We hear this term constantly in engineering circles now. It sounds so casual, but in an enterprise context, it is actually terrifying. Define that for us.
It is exactly as casual and terrifying as it sounds. A developer goes to an AI assistant, Copilot, Cursor, Windsurf, whatever it is, and gives it a prompt. Let's say, write a Python script to normalize this customer data and remove duplicates.
Common in a task.
Very common. The AI spits out 20, maybe 30 lines of code in a second. The developer glances at it. They're not reading it line by line. They're scanning it.
What are they looking for?
The vibe. Does the indentation look correct? Are the variable names sensible, like customer and transaction value? Does it, visually resemble code that they would expect to see?
So it looks plausible.
It looks plausible. The vibe is right. And so they commit it. They merge it into the main branch.
Without actually running it through a rigorous test. Or even understanding the precise logic the AI used.
In many, many cases, yes. They are treating the code output like a Google search result. You trust the top answer. You don't, go and verify the primary sources for every search you do.
And this behavior is what's leading to what GitClear is calling silent failures.
Yes. And we have to distinguish this from a normal bug.
Right. In the old days, if I wrote bad code, the compiler would scream at me. The whole thing would just stop.
That's a noisy failure. A syntax error crashes the build. The app doesn't open. The website gives you a 500 error. It's annoying, sure. But in a way, it's safe.
Why safe?
Because it stops the production line. You know it's broken immediately before any customers are affected. A silent failure is so much more insidious.
Because the code runs.
The code runs perfectly. The app opens, the dashboard loads, the numbers appear on the screen, everything looks fine. But the logic, deep underneath, is subtly corrupted.
The source material gave a really specific and I thought chilling example of this with data cleaning. Could you walk us through that?
Absolutely. So imagine that Python script I mentioned. You've asked the AI to clean a big data set of financial records for your company. The AI writes a script, you vibe check it, you commit it, and it runs.
Okay.
But maybe deep in the logic on line 14, the AI has, for whatever reason, hallucinated a condition that says, if the transaction ID is divisible by 10, drop the row.
So it's just deleting every 10th customer transaction. Silent.
Silently. Or maybe it's even more subtle. Maybe it truncates decimal points on currency values instead of rounding them. So $99.99 becomes $99.
And over millions of transactions, that's a fortune.
A fortune. And the worst part is there is no red flashing light. There is no error log. The only way you find out is 3 months later when your CFO says, why are our revenues down by 1.2%?
And then you have to find the ghost in the machine.
And you can't find it because the developer who committed the code didn't write it themselves. They don't have that mental map I mentioned earlier. They don't know where to even begin looking.
So what's the cost of that? What does the data say about fixing these things?
This is the stat that just destroys the whole 10x efficiency argument. The data from GitClear shows that debugging these silent failures takes, on average, 40 to 60% longer than if the human had just written the code carefully from scratch in the first place.
That is just, It's a productivity sinkhole. You save 5 minutes on the generation, but you lose 3 days, maybe a week, hunting for a bug you can't see.
You're hunting for a needle in a haystack, but you don't know which haystack to look in or even what a needle looks like in this context. And this is reflected in the most damning stat from the whole audit, in my opinion.
Which is?
The collapse of refactoring.
Okay, for the non-engineers listening, let's just quickly define refactoring.
Refactoring is the hygiene of software development. It's the essential but often unglamorous work of cleaning up existing code. You're simplifying it, making it more efficient, removing redundancies, all without changing what it actually does.
It's like cleaning the kitchen as you cook.
It's exactly like that. It's how you prevent a system from decaying into an unmaintainable mess. It's how you keep a code base healthy over time.
And according to the GitClear audit, refactoring has.
It has collapsed. It's down by 60%.
60%. That is a staggering number. That's not a dip. That's a cliff.
It is catastrophic. What we're seeing is that commit volume, the amount of new code being added to systems, is at an all-time high. Everyone's productive. But the maintenance, the cleaning, the care of that code has evaporated.
Why? Why are developers not doing it?
Because reading and understanding AI-generated code is often much harder than reading your own code, or even code written by a colleague. The cognitive load is too high. The AI doesn't think like a human. It might use bizarre variable names or needlessly complex logic.
So developers don't want to touch it.
They don't want to touch it. They'd rather just prompt the AI to write a new function and bolt it on top of the old stuff. So what you get is this. We're piling new floors onto a skyscraper without ever going back to check and reinforce the steel beams in the foundation.
It's the literal definition of a bubble. We are inflating the size of the code base without the structural integrity to support it.
Exactly. And to compound this problem, the audit found that code duplication, literally just copy-pasting the same blocks of code over and over, is up by 48%.
Which violates the cardinal rule of software engineering, DRY. Don't repeat yourself.
The absolute cardinal rule. You're taught this on day one. Because if you have a bug in one function and you've now pasted that function into 50 different files across your application...
You don't have one bug anymore. You have 50 bugs.
You have 50 bugs. And because of the vibe check culture, you probably don't even know they're there. We are building these massive, sprawling code bases that are physically larger, but structurally so much weaker. We are actively prioritizing volume over value.
It's a house of cards. But there's another layer to this rotting foundation. And it's not just about quality. It's about security. We have to talk about the Gnostic research in this idea of shadow AI.
Yes.
This isn't just about bad math anymore. This is about accidentally giving away the keys to the entire kingdom.
This is the security nightmare that I think C-suites and boards are only just starting to wake up to now in 2026.
So what's the mechanism here?
Okay, so tools like Windsurf and Cursor, which are incredibly powerful and developers love them for a reason, they work by being context aware. To give you good, relevant code completions, they need to understand your project.
So they read your code.
They do more than that. They ingest your entire project folder, they read your file structure, they index your function names, your class definitions, all of it.
Which is why developers love them. The tool knows your variable names, it knows your internal APIs. It feels like magic.
It does, but here's what else it ingests. It ingests your .env files.
Oh, for the non-technical, that's where you store
your secrets. Your database passwords, your API keys, your server configurations. Gnostic's research found that in a shocking number of enterprise environments, these helpful AI assistants are effectively exfiltrating sensitive corporate secrets the moment the developer loads their IDE.
So let me get this straight. You're a developer, you're typing away, feeling incredibly productive because this tool is helping you write code faster. And meanwhile, your company's AWS credentials and your Stripe payment keys are being tokenized and uploaded to a third-party cloud inference engine.
That is effectively what is happening. They call it secrets leakage, and it's a silent failure of governance. We used to spend millions, tens of millions on complex firewalls and security systems to keep hackers out.
And now we're just inviting the spy into the living room and giving them a key.
We are, because the spy helps us write code faster. It's a complete breakdown of risk management. So when you put it all together, you have insecure houses being built on top of rotting, silently failing foundations.
That perfectly establishes the first crisis, the engineering collapse. But, okay, this brings us to the second and maybe more confusing crisis. If the code is rotting, surely the United States, the country that invented this tech, the home of OpenAI, Google, Microsoft, Anthropic, surely we are still the global leaders in actually using it, right?
Yeah, we must be. You would assume that. I mean, it's a logical assumption. We have the capital, we have the data centers, we have the talent.
But the data says the exact opposite.
This is the macro crisis. The Microsoft AI Economy Institute just released their big 2025 report, and I have to say, I read it and I was floored. The U.S. is ranked 24th globally in what they call AI diffusion.
It's a shocking number.
It is. We are behind Taiwan, we are behind South Korea, we are behind the UAE, we're barely ahead of Germany. How is it possible that we possess the means of production, but we are failing so badly at the means of consumption?
The report identifies this phenomenon with a really interesting term. They call it Innovator's Inertia.
Innovator's inertia. Okay, unpack that for me. In short, it stems from the fact that the U.S. economy is, in many ways, a victim of its own success. It's mature, it's incredibly complex, and it is heavily regulated.
So we're too successful to innovate. That feels paradoxical.
It is. But think about the technical debt we just discussed in a single code base. Now, Apply that concept to the entire U.S. economy.
Okay.
A major U.S. bank, one of the big ones, is likely running its core transaction ledger on a mainframe system that was built in the 1980s.
And probably written in a language like COBOL.
Almost certainly. Now, surrounding that ancient core are dozens, maybe hundreds of layers of other technology, SaaS stacks from the 2010s, APIs bolted on, middleware.
It's a giant, precarious Jenga tower of technology built over 40 years.
Precisely. Now, imagine trying to integrate a fluid, probabilistic, occasionally hallucinating AI agent into that rigid, brittle architecture. It is a technical and a compliance nightmare.
Because if you break the mainframe, you don't just break an app, you stop the bank.
You stop the bank. You stop the flow of money. The risk is astronomical. So corporate immune systems in the U.S. are, by default, rejecting the transplant.
Compare that to the countries at the top of the list. Who is number one?
The United Arab Emirates, the UAE. They have a 64% diffusion rate, according to the report. It's off the charts.
64%. What on earth are they doing that we aren't?
They're approaching it from a completely different philosophical standpoint. They are treating AI as public infrastructure.
Not a product.
Not a consumer product you buy off the shelf. They're treating it like electricity or the highway system or water treatment. It is a state-directed command economy imperative from the top down.
So the government is effectively saying, this is the new grid, here are the standards, now everyone plug into it.
Exactly. And crucially, they are often building on greenfield infrastructure. They don't have 40 years of legacy banking code to fight their way through. They can build new systems from the ground up that are AI native.
They're designing the city for the self-driving car from scratch. Well, we're just trying to squeeze the self-driving car onto a cobblestone road from the 1800s.
That is a perfect analogy. And then there's the second major factor, which is the legal one. The U.S. is an incredibly litigious society.
The fear of being sued is a huge driver of corporate behavior.
It's the primary friction point for AI adoption. The regulatory environment here incentivizes extreme caution. If you're an executive at a U.S. company and you deploy an AI that hallucinates a loan denial based on a protected class like race or gender, you are going to get sued into oblivion. The liability frameworks here are just... they're murky at best.
And in places like the UAE or South Korea.
In places like the UAE, or especially South Korea, which is the fastest growing on the list, up almost 5% in just 6 months, the government is not just encouraging adoption, it is mandating it and clarifying the rules of the road at the same time.
So they're removing the uncertainty.
They're removing the uncertainty, which is the biggest killer of corporate investment. South Korea, for example, is dealing with a massive demographic crisis. They have a rapidly aging population and a plummeting birth rate. They need automation to maintain their economy and their healthcare system. It's a matter of national survival for them.
So for them, it's not a cool app or a new chat window. It's essential plumbing for the future of their country.
It's the plumbing of their economy. Whereas in the U.S., we are still largely treating AI like a consumer gadget. And that's a huge strategic error.
The report also touches on something called cognitive infrastructure. This digital divide isn't just about who has laptops, it's about who has the skills.
This is a really crucial point. You can give a country the most powerful AI models in the world, but if the population doesn't have the skills to use them effectively, they're completely worthless.
What do the numbers look like there?
There's a stark divide. In what the report calls high-income countries, about 66% of the workforce has the baseline digital skills needed to integrate and work alongside AI. In low-income countries, that number is less than 5%.
Less than 5%.
A huge gap. But here's the twist for the U.S. We're a high-income country. We have the skills. We have the talent. Our problem isn't a skills gap, it's a usage gap.
We know how to use it, but our corporate immune systems, as you said, are rejecting it.
We are paralyzed. Paralyzed by the risk of those silent failures we talked about. Paralyzed by the complexity of our legacy systems, and paralyzed by legal liability. And that paralysis, that innovator's inertia, is costing us our global competitive edge.
If we don't figure out how to integrate this substance into our legacy economy, we will lose the productivity race to nations that are simply able to move faster and with more top-down conviction.
That's the core warning of the report.
Okay, so speaking of moving faster and, actually cutting through that red tape, I want to pivot to our third crisis, the agency gamble. Because while the macro numbers for the U.S. look really bad, there's one specific sandbox in America that is actually getting it right.
Yes.
And weirdly enough, it's Utah.
The Utah sandbox. This is probably the single most important story in this entire substance pivot that the mainstream tech press is almost completely ignoring.
I agree. So let's set the scene. It's this month, January 2026. The Utah Office of AI Policy announces a partnership with a startup called Doctronic. And they do something that, to a traditionalist, sounds like complete malpractice.
It sounds radical.
They're letting an AI authorize prescription refills without a human doctor reviewing every single transaction. When I first read that, I thought, that's insane.
It sounds insane, but when you dig into it, it is the absolute definition of operational substance. They didn't just throw technology at a problem, they looked at the right problem to solve. Routine medication management. We are not talking about the AI diagnosing a rare form of cancer or recommending experimental surgery. We are talking about refilling prescriptions for blood pressure medication, for cholesterol, for thyroid issues.
Things people take for decades, where the dosage is stable and the condition is known.
Exactly. The current system, the human in the loop, is mostly administrative theater. As a patient, you have to call the clinic, maybe make an appointment, pay a copay, take time off work, just so a doctor can spend 30 seconds looking at your chart and signing a piece of paper.
It's all friction and cost.
It's all friction and cost. A simple clinic visit like that can cost the healthcare system $100 or more, all in. The Utah pilot allows the AI to access the patient's history, check their recent vitals against the established protocols, and if everything is within the standard deviation.
It just authorizes the refill. No human needed for that specific transaction.
Correct. And the economics are just staggering.
What's the cost per transaction now?
The cost drops to $4.
From over $100 down to $4. That's not just efficiency. That is massive systemic deflation in healthcare costs.
It's incredible. But, and this is the big but that everyone immediately asks.
What happens if the AI screws up?
Yes.
What happens if it refills a medication that interacts with a new drug the patient is taking and it harms them? Who goes to jail? You can't put an algorithm in jail.
This is the genius of the Utah model. They didn't try to solve a technology problem. They solved a legal one. They created a new legal framework that they call doctor, not device.
Doctor, not device.
Yep.
Okay, explain the legal mechanics of that. It sounds important.
It is the whole ball game. What it means is that legally, the AI is not considered an independent actor. It is treated as an extension of the supervising medical director. It's a tool, just like a stethoscope or a scalpel is a tool.
So if the scalpel is faulty, you don't sue the scalpel. You hold the surgeon accountable.
Exactly. They didn't dissolve liability. They anchored it. They made it crystal clear. The AI does the work, but the human medical director retains 100% of the legal and professional liability for its decisions.
So they didn't try to pull some sci-fi move and say the robot is now a person with legal rights. They just said, doctor, this robot is your really powerful lever, but if that lever breaks and hurts someone, you bought it.
You bought it. And because that liability is so absolute and so clear, it forces the technology company, in this case Doctronic, to have every possible incentive to make sure their tech actually works. They can't hide behind a long terms of service agreement or a disclaimer.
Their customer, the doctor, is on the hook, so they have to deliver a bulletproof product.
And they did. The safety metric they had to achieve to get this pilot approved was 99.2% concordance with the decisions of human doctors.
Which is likely higher than the concordance between two different human doctors.
It almost certainly is. It works because the accountability gap is closed. It's a brilliant piece of social and legal engineering, not just technological engineering.
Now, let's contrast that incredible success with the absolute disaster at Air Canada. This is the perfect anti-pattern.
Oh, the great bereavement fair debacle. This is the classic case of what happens when magical thinking crashes headfirst into legal reality.
For those who might have missed this saga in the news, a man's grandmother passed away. He needed to book a last-minute flight, so he went to the Air Canada website and asked their chatbot about getting a bereavement fare.
Right. And the chatbot, in its infinite wisdom, said, absolutely, just buy the full price ticket now and you can apply for the discount retroactively within 90 days.
Which was a complete hallucination.
A total fabrication. The actual human written policy was that you must apply for the bereavement fare before you travel. The bot just made up a nicer, more customer-friendly policy.
So the man follows the bot's instructions, buys the ticket, and then later applies for the refund. And Air Canada, of course, says no.
They say no. He sues them in Canada's Civil Resolution Tribunal. And Air Canada's legal defense was, it was honestly breathtaking in its audacity.
It really was. What did they argue?
They argued that the chatbot should be considered a separate legal entity.
A separate legal entity.
Yes, they effectively tried to argue that the chatbot was a rogue employee that they weren't responsible for. Their official argument was that the user should have known better than to trust the chatbot and should have double-checked its answer against the static PDF of the real policy buried somewhere else on the website.
The tribunal, I assume, did not buy that argument.
They laughed them out of the room, metaphorically. The ruling was swift and unequivocal. The tribunal said, in essence, if your bot says it on your website, you said it. You are liable for the information you provide to customers, regardless of whether a human typed it or a machine generated it.
And with that one ruling, the idea of a corporate liability shield for AI just died. You cannot hide behind the black box.
It's dead. And we saw the exact same dynamic play out, just in a different way, with Klarna.
Klarna, the buy now, pay later company, this was a huge story. They famously laid off 700 customer support agents, claiming they could be replaced by an AI system. It was the poster child for AI-driven efficiency.
It was. The CEO was on every business news channel talking about the future of work. Until May of 2025, when they had to quietly reverse course and start rehiring human agents.
Why? What broke? What did the AI fail at?
It failed at the human stuff. The AI was actually great at handling the simple transactional queries, things like, what is my current balance? Or when is my next payment due?
The easy stuff.
The easy stuff. It couldn't handle the hard stuff. It couldn't handle the silent failures of empathy and context. It had no idea what to do with the customer who was saying, I think my account has been hacked and I'm being defrauded and I'm scared.
Or, I'm furious because you overcharged me and your system is broken.
Exactly. It couldn't de-escalate an angry customer. It couldn't provide genuine reassurance to a frightened one. It turns out that for high-stakes customer service, the new premium product is biological intelligence.
So Klarna discovered that if you want to actually retain customers during a crisis, you need a human being.
They did. They even pivoted their brand messaging to be about how they are now the best at offering a human to speak to. It was a complete 180.
So the lesson from this whole operational frontier is, you can automate well-defined tasks where liability is clear, like the Utah prescriptions. But you cannot abdicate liability, like Air Canada tried to do, and you cannot automate genuine human empathy, as Klarna learned the hard way.
That's it exactly. Substance means knowing the crucial difference between a task and a relationship.
All right, we have covered the code, the nations, and the law. We now have to talk about the money. Because nothing, I mean absolutely nothing, has sobered up this industry quite like the event we're calling the DeepSeek shock.
This was the moment the floor just fell out from under the entire Western AI business model. It was an earthquake.
So, set the scene. January 2025. A Chinese AI company called DeepSeek releases two new models, V3 and R1. And the number that sent shockwaves through Silicon Valley wasn't their benchmark score, though that was impressive. It was the price tag.
The training cost, which was approximately $5.6 million.
$5.6 million. We need to put that number in context. Before this, what were companies like OpenAI and Google and Anthropic spending to train their flagship models?
The public estimates for models like GPT-4 and Gemini Ultra were anywhere from $100 million on the low end to nearly $200 million on the high end for a single training run.
So the entire venture capital model, the whole moat theory of this industry, was predicated on one idea.
The idea was you need billions of dollars in capital, and you need a private fleet of tens of thousands of top-of-the-line NVIDIA H100 chips to even play the game. It was a game for giants only.
And then this relatively unknown Chinese startup comes along and does it for, what, roughly 5% of the cost? The immediate question is, how? Did they just cut corners? Was it just a much worse model?
And that's the scary part for the Western incumbents. It wasn't worse. In some key benchmarks, especially for coding and mathematics, it was actually better. They didn't cut corners. They innovated on the fundamental architecture. This is pure technical substance.
Okay, so what was the key innovation?
They leaned heavily into an architecture called Mixture of Experts, or MOE.
Let's try and break that down simply without getting too bogged down in the math. How does MOE save so much money?
Okay, so imagine a traditional dense model, like an older version of GPT. You can think of it like a giant library. Every time you ask it even a simple question, it has to metaphorically run through the entire library and read every single book to come up with the answer.
Which burns a massive amount of energy and compute time.
A massive amount. And MOE model is different. It's like having a team of smart specialist librarians. When you ask a question about, say, biology, The head librarian says, oh, that's a biology question. I'm only going to wake up the biology expert and send them to the biology section of the library.
So instead of activating the entire brain for every thought, it only activates the relevant neurons for the specific task.
That is a perfect way to put it. The full DeepSeek model has 671 billion parameters, which is huge. But for any given word it generates, it only activates about 37 billion of them. It is hyper efficient.
But that wasn't the only innovation, right?
Yeah.
There was something else.
Right. The real breakthrough, the part that other labs are scrambling to replicate, was something they developed called MLA, which stands for multi-head latent attention.
MLA. Why does that matter to a CEO or an investor?
Because it solves the single biggest bottleneck in running these large models. Memory. It's a new technique that dramatically compresses the key value cache, which is a fancy way of saying it drastically reduces the amount of memory bandwidth required to operate the model at high speed.
Okay, and here's the geopolitical irony of the whole story. They had to invent this.
They were forced to. Because of U.S. sanctions, Chinese companies like DeepSeek were blocked from buying the top-tier NVIDIA H100 chips.
Which have the highest memory bandwidth.
Exactly. They were stuck with the slower, export-controlled H800s. They hit a hardware wall imposed by Washington. So what did they do? They innovated their way around it with better software.
Necessity is the mother of invention. The hardware blockade literally forced them to write more efficient software, and in doing so, they leapfrogged their Western competitors.
They completely out-innovated the constraint. And the economic result of this is that the intelligence premium is now officially dead.
It's gone. That idea that access to a frontier model is a rare, expensive thing that you can charge a high margin for, that's over.
It is over. Intelligence is now a commodity. It's like wheat or rice or bandwidth. There will be high-end premium versions, sure, but there will also be a massive supply of good enough intelligence at near zero marginal cost.
So how does this change enterprise strategy? Before DeepSeek, companies practiced what you called model monogamy.
Yes. You'd sign a massive multi-million-dollar enterprise contract with OpenAI or Google, and you'd route every single API call your company made to GPT-4 or Gemini.
Because you assumed you needed the best, most expensive model for every single task.
Right. But now we are seeing the rapid rise of the good enough strategy enabled by something called model routing.
Okay, give me a real-world practical example of what model routing looks like inside a company.
Okay, take a large logistics firm. They have to process, say, tens of thousands of scanned shipping manifests every single day. The main task is just basic optical character recognition, or CR. They need to extract the date, the sender's address, and the package weight.
A simple, repetitive task. You don't need a PhD-level intelligence to read a date off a scanned PDF.
Exactly. You need the intelligence of a high school intern, basically. So the company's new model router automatically sends that simple, high-volume task to the cheap DeepSeek model or a fine-tuned open-source Llama 3 model for fractions of a penny per document.
But what if there's a more complex task?
That's the key. Let's say the system flags a document that isn't a manifest, but is a complex legal contract with an unusual liability clause. The router is smart enough to identify that this is a high-stakes, high-reasoning task.
And it sends that specific task to the expensive high-trust model.
It sends that one to OpenAI's O1 or Anthropic's Claude and pays the premium for that specific job. You use the right tool for the job rather than using a sledgehammer to crack a nut.
So the business model of just charging $20 a month for a subscription to access general intelligence is now structurally broken.
It's completely broken. The margin has been competed away by commoditization. The value is no longer in owning the model itself. The value is in the application layer, the routing system, the legal liability framework like we saw in Utah, the integration with your proprietary data.
It really is a great sobering. In the space of 1 year, we went from AI is scarce and magical to AI is an abundant commodity that needs to be carefully audited and routed based on cost.
And that really brings us to the conclusion. The big question now is, where do we all go from here?
Yeah, let's wrap this deep dive up with some tactical, actionable advice. If I'm a leader, a CTO, a CEO, listening to this in early 2026, what do I do tomorrow morning? Nadella says, from spectacle to substance. What are my new KPIs? What should be on my dashboard?
You have to fundamentally change what you measure. First and foremost, you need to stop measuring time to hello world. Stop celebrating how fast your team can build a flashy demo. That metric is now poison.
Because it encourages the vibe check culture.
It encourages speed over quality. Instead, you need to measure 3 new things.
Okay, hit me. What's number one?
Number 1 is time to trust. This is your verification latency. If your AI agent completes a task in 5 seconds, but it takes a human employee 10 minutes to carefully verify that the output wasn't a subtle hallucination, you haven't gained productivity. You've lost it.
So you need to build automated verification systems, like unit tests for your prompts.
Exactly. How fast can you prove the output is correct and trustworthy? That's your new speed metric.
Okay, that makes sense. What's number two?
Number 2 is refactoring ratio. You need to go to your engineering leadership tomorrow and ask them this specific question. Show me the data. Are we cleaning our code, or are we just piling AI-generated slop on top of our existing technical debt?
So you look at the ratio of lines of code deleted or improved versus new lines of code added.
Yes. If your refactoring rate is dropping while your commit volume is skyrocketing, you are building a ticking time bomb in your infrastructure. You need to start incentivizing the deletion and simplification of code, not just the creation of it.
Okay. Time to trust, refactoring ratio. And number 3.
Number 3 is agent health. You cannot just deploy these AI agents and forget about them. You need to be constantly monitoring for silent failures. You need tools that act like a heart monitor for your AI systems, checking for statistical drift, for emergent biases, for those subtle logic errors that won't throw an error code.
You have to treat it like a living system, not a static piece of software.
Precisely. The era of set it and forget it is over. This is an era of constant vigilance and auditing.
It really does feel like the era of the vibe check in every sense is truly dead.
It has to be. You know, if the U.S. wants to climb back from that number 24 spot in global adoption, if we want to catch up to the UAE or South Korea, we have to stop treating AI like a magic trick or a cool app. We have to start treating it like electricity.
It should be boring.
It should be boring. It should be reliable. It should be auditable. And it should be everywhere, powering the real substantive work of the economy. Boring is the new exciting.
Boring is the new exciting. I like that. In 2026, it's true.
Absolutely.
Here's my final thought for you listening today. We've talked a lot about auditing code and auditing agents and auditing data, but I think the most important thing you need to do tomorrow is audit your own expectations. The benefit of the doubt period for this technology is over. If you're building something or if someone is selling you something, don't tell me it's game-changing. Tell me it's auditable. Tell me who goes to jail if it breaks.
That's the new standard.
That's the new standard for substance. Go audit your code bases. Go audit your agents. The party is over. Time to get to work.
Time to clean up the mess.
Thanks for listening to AI Unraveled. We'll see you next time.
That wraps up our deep dive into the substance pivot. The signal for today is auditability. The era of the vibe check is dead. You can no longer just look at AI output and nod. The winners of 2026 will be the companies that build the audit layer, the systems that catch the silent failures, verify the prescriptions, and validate the code before it hits production. If you can't measure it, you can't trust it. Before we go, a reminder for the leaders listening. Are you drowning in dense legal text? DjamgaMind is the new audio intelligence platform that decodes liability so you don't have to. Start your specialized audio briefing today at DjamgaMind.com. This podcast is created and produced by Etienne Newman. Please subscribe and share. Until next time, keep unraveling the future.